Hello, welcome back to another edition of Show and Tell Monthly. We are in our December edition, which means we have almost done a whole. Actually, I think that does mean we have now officially crossed over and done one whole year of monthly show and tells, which has been really fun and really cool because I feel like we've gotten to see and hear about a lot of really amazing projects over the last year. Um, and we're just going to keep hearing about really fun, cool projects as the time keeps going, which is really rad because we are now almost at 3,200 certifications. So that's a pretty big number, and we're really excited to just keep seeing that grow. If you haven't certified your work yet, maybe you want to get your certification in before the year's up, or maybe that's your New Year's resolution. Get your certs in. We always like to see new certs. Um, as far as things going on at Oshawa, since we are hitting end of year, we're getting pretty excited to kind of cool down for a couple weeks and chill out. But we still have our Open Hardware Summit 2026 call for proposals is out and it is due on the 21st. So that's just 3 days away. So if you have not put in your proposal, now is a great time to do that. You could do it while watching the stream. You could really double up on your activities today. There's lots of time to get that in, but still 3 days isn't too long. But I know that y'all tend to work on tight deadlines and last minute schedules. The ADHD in this community is large. So get that in so that we can have you at the summit next year in Berlin, May 23rd, 24th. So keep that in your calendar as well. If you don't have that in there yet, probably a good time to add it. Today we've got 3 really rad projects. I'm really stoked. We have some pretty cool stuff that has come out in over the course of a couple months. Actually, these weren't all certified in November, but they are ones that we wanted to get in before the end of the year. So we're going to get started. Our first guest is Michael DeRocco. Hey, Michael, how's it going?
Hello, hello everybody. How are you?
Good, good.
Yes, this time I have more time to present because last time I had just 5 minutes because yeah, I remember, but it's not a problem. I have some slides to present what I did and about the project also. Check.
Yeah, for those who were tuning in on our uh, big 12-hour live stream,
Yeah,
Michael did have a very short time slot, so
yeah.
we wanted to make sure to bring
So
him back so we could
do you
talk about it
show? Yeah.
more.
Do you show my screen? Do you see my
Yep.
screen? Okay, nice. I just enlarge. Okay. So just a quick introduction of what I did, my point of view of open hardware and my workspace and the project where I build and the next steps of the project and of my initiative. So who you are, I set up a brand in June, Mighty Trodic, just to have a hardware design studio acting on 2 dimensions, I would say, one for commercial, another one for open source. That's why we are interesting to help guys to concretize their prototypes to go to production or to build more reliable hardware, meaning in PCB. What was new since last time? Since recently, last week, I passed successfully my PCB designer certification. It's a IPC designers. It's a standards, international standards for manufacturing in DFM, DFT, and DFA for assembly to have the best practice when you design a PCB. That I heard last time, and the project is after to help and to review design for makers, startups, and innovators. So that I propose for the open source community. It's the same more or less for commercial, but for only for guys dealing with open source project. I can organize workshops, design review, hardware and software also with reliable code. Can provide some full documentation of some boards I did. One of the first is Little Green, and I have others stuff in project like for motor interface and so on. I can give also free resources for PCB guidelines, firmware, library, and so on. Why for me open hardware it's important. First for transparency, to have a nice collaboration with a large community. It's a quick win because I can test with open hardware and I receive. It's always the same. You give, we receive, and I can improve my skills on some design domain, like for schematics, CAO, and so on. This is just a brief overview of where I build some project, and sometimes I repair some vintage audio equipment. With some oscilloscopes. I have my CNC for quick prototyping. Okay, so for the project, Little Green was first in Luxembourg certified. I was the first, so yes, with a lot of 0001. This project was an idea just to give the opportunity to have a kit for people who wants to learn electronics and embedded systems. It's just a very simple kit, I
Michael,
would
so
say.
sorry to interrupt. Right now, all we can see is a file browser. Are you showing?
Ah,
Maybe we
oh,
didn't swap
let me check.
items that were being presented.
I don't know why, because I didn't. Up, and now it's better.
There we go. Yeah.
Okay, okay. Tell me if come back. So yes, for this project, it was just a simple kit to help to manage automatically your greenhouse. Could be a small indoor greenhouse or outdoor, as you wish. I put all the stuff in GitHub for schematics, PCBs, of course, libraries and code source. The goal of this project is also to you could customize because you can add some controls for moisture with ventilation. You can add more sensors or other stuff for a bigger greenhouse, for example, if you are more fan for hydroponic or aquaponic systems. Yes, just as you wish, you can adapt the stuff. Here is a very basic approach to for people who wants to learn. Again, it's intentionally it's not connected. It's not an embedded system with Wi-Fi or Bluetooth or whatever to simplify the learning for guys are wants to learn progressively electronics and embedded system. Here it's just a small OLED displays with some 4 buttons like for Nintendo Switch, the colors. There is a pump to for watering the soil, depending of what you want to plant. It could be herbs, could be tomatoes, what you want. There is a small captor for humidity and temperature, one for the soils, and the soil captor, the pilot, the pump, when you can trigger the humidity. And with the 4 buttons, you can set up everything we want in terms of trigger, light duration, because there is a small LEDs to boost the growth of the plant. And you can also set up how many times you want to light your plant. And very basics. Huh? And you have also a real-time clock to program the stuff. It just with 4 buttons with a very simple function. One, it's unit control, of course. Simple power supplies with 24s and 5 volts. 24 volts is just for the light, and 5 is just for the pump and the microcontrollers and the other captors, sensors, sorry. And you have some power interface function for lights and pump. And we have also read some function for reading temperature, humidity, soils, displaying data, dealing with the real-time clock. Also, you can also, of course, set up the date and the real-time clock. It's like and the setup function. Here is the schematic. I just split just to see which to map the right function with these slides. And yes, it's based on the very small Arduino Uno, but now the goal is to build a real board with all best practice. Here it's just a very quick prototype for the moment. I have to update it and to upload again in the open source site. Here you have just very small and very easy component to find, like the relay for the lead. You have some pump you can find very easily. It's the same pump, for the aquarium for you, and you have to put some product for fish and so on. You have the famous DHT11, the DS32, 31 for the real-time clock. You have it's very classical, classics component. Here it's when I built the PCB for this project. I don't know if you know these techniques. It's just very simple. I just put some paints on the coppers, and the laser burns the area I want to remove by chemical product like perchlorate. So, and this is the results after the gravure with the lasers and after the chemical treatment, and after just to drill and to assemble the component. So, and this is the works light prototype, I would say. Just build with a few pieces of wood I take in my garage, and I fix it on my kitchen. It's yeah, and you can adapt with some greenhouse. You can find easily in the many garden shops, or you can build yourself if you like it. And I put in the very simple box the PCBs to integrate. And here it's just to and yeah, and here I plant some basilic, and works very nice for all things like this, or for some small cherries, tomatoes, and so on. So this is certification. I share also the QR code for the code source and schema. And yes, and now what's the next? Now I'm more working on the design to have something more professional, meaning in terms of PCB designs, and not to use a development board, to have a real MCU directly programmed, but to let the opportunity, even if it's a kit, to add your own connectors and so on, just a fixed product to enable the guys to play with it and to add some new functionality. The next, I'm working on it, but it's more or less linked with the first kit. It's more motor control, universal motor control for servo motors, step motors, classic motors with continuous electric motors, to pilot this with I2C bus, and probably I will use the same for my ticket for all the stuff we need to activate some motors like pump and ventilation and so on. So now what in parallel, what I try to show to looking again, is to have some pilot project in open source. If you are interested to join the initiative and to share, or you have a project and you want in open source, of course, and you want just to have a design review, some feedbacks of many things during the different step of the conception, just feel free to contact me and you can try to work together. It's just for me a pilot, and again to share with the community, and each of them come back with something new, or with new learnings, new knowledge. That's it. Again, thanks again for the to let me to present the project.
Yeah, thank you so much for coming on
you.
and giving us a rundown. It's actually so cool that this is our first certification from Luxembourg.
Yeah.
Which that was actually this is such an irrelevant question. Is it Luxembourgian, Luxembourg?
For the name of the country, hey, just Luxembourg.
Just Luxembourgian. But it's really cool to have y'all on the map, and I'm really
Yeah,
excited to see more certifications come in because it looks
yeah,
like you've already got a lot more ideas on the on the mind.
yeah. I try to make some promotion to other guys on board, but in Luxembourg, yeah, it's a bit difficult to find some motivated guys, but yeah, I try.
It's also really cool that you are cutting your own PCBs. A lot of people do not do
Yeah,
this anymore because it's
yeah,
such a
because
stressful
I
experience.
try to put in production for to commercialize because okay, you can be open source, but you can sell the PCB already done, of course. And when I try, you have a lot of regulation behind, especially on compatibility, electromagnetic compatibility, and so on. I deep dive on it. I find the IPC, it's a US standard now around the world, and I passed my certification last week in Paris. I was very tense program because there is real engineering in electronics and hardware design and so on. And I realized many guys have just a prototype, and it's sometimes very difficult to integrate to distribute. And you
Yeah.
have to, and there is a lot of, especially when you send the PCB to the manufacturer, you think like a conceptor, a designer, but behind there is some machine. Sometimes it's diameter of the holes, or the manufacturer has not the capability to do what you did because it's too much accurate, or the price could increase also
Hmm.
thanks to the quality. That's
Yeah.
why now I try to propose this service and to onboard this by design immediately and not after, because after it's a bit too late sometimes because you have to redesign everything. Yeah,
Yeah. Yeah. I also like so often with open source projects, people like they'll send it off for production, and then it's getting their first version of the board produced, and then
hmm,
they're like, wait, I've already figured out things I should have done better.
yeah,
So
yeah,
it's nice to be able to keep that in house and get to make those
yeah,
adjustments as it's happening instead of having to be like, okay, so I just wasted money on this first production run because I already figured out how to make it better.
yeah. That's why. And if there's some guys in the community struggling with this or with just some advice, just feel free to share and to contact me. I will be happy to participate.
Amazing. Thank you so much, Michael. It was really rad
Okay,
to
thank you.
see more about the project.
Yeah, bye bye.
Bye, Michael. Yeah, really cool project. I am a certified plant killer, so anything that helps keep a plant alive seems really important to me because they will not stay alive in my house. Between me and my cats, it's zero-sum game for those guys. Next up, we've got a really rad project from Nathaniel Nifong. Hey, Nathan, how's it going?
It, I tried to keep a pepper plant alive in my house one time, and those things are very susceptible to viruses. So if you ever want to pick a plant, don't pick black pepper.
Yeah, I wasn't gonna do that.
So
I can barely keep aloe vera alive, which is supposed to be
yeah, oh, that
super
was
easy. So, what have you been working on?
Well, I have been working on a robot to clean my house, and I want a robot to clean my bedroom because I see demos for cool robots getting better and better every day. But I know that they're going to be thousands of dollars, $20,000 for a dog, 10,000, $100,000 for a humanoid, and I know we can do better than that. So a robot morphology that has as few actuators as possible is going to be cheaper. And oftentimes you'll see like people saying, well, this new bot has 39 degrees of freedom, and as if that's like a selling point. But really, that just makes training harder. And that makes the price go up. And with a cable driven parallel robot, you can reach a whole room with like 4 motors. So that's what I'm building. And basically, if I start the controller here, I can drive this around with a gamepad. It is hanging from the corners of the room by 4 of these. And this mostly what you'll see here is the cover for this device, but I'll pull the cover off in a minute and show you what's inside. But it's a spool motor. It's a motorized spool and a little Raspberry Pi in there that just connects to the Wi-Fi. So there's one in every corner of the room, and they pull on the spools to the right length so that this thing hangs at the right spot. And there's a camera in every single one that sees where it is and helps me calibrate. And there's a gripper hanging from it. And it's just 2 fingers. That's pretty much all you need. I mean, I know you can make really dexterous and amazing robot hands, but 2 fingers, grip tape, and like a pressure sensitive resistor is good enough for 80% of the stuff you want to pick up. And like with socks, there's no way to pick up a sock wrong. If you get anywhere near the sock, you're going to pick it up. So basically, I've got my control here, and I've got it configured so that basically wherever I am, it's going to orbit around me. So when I stick left, it's going to orbit me counterclockwise, and when I push stick forward, it's going to move away from me. So basically, I can take this thing and drive it over there, and oh, there you go. When people watch, it tends to fail. That's what's actually happening when the motors miss a step, because right now I'm driving it with NEMA 17 stepper motors. And the faster you move a stepper motor, it turns out I've learned, the less torque it can apply. So you need a certain amount of torque with one of these, because the higher you go, the more you're pulling on these lines. And I in the future, I will be using bigger motors. I'm sure not the first person to say that, but we have a robot that can drive around in the air and pick up pretty much anything in this room and drop it somewhere else. So what I've programmed it to do right off the bat is pick up socks. And what we're going to do is we're going to have a trial by fire, because believe it or not, I programmed this to pick up black socks off of the carpet. And the network is trained to recognize these black socks and send the robot towards them, pick them up, and drop them in the hamper. And the hamper is like marked with a tag like this. The hamper has a tag on it. I'll point you at it in a second. So the reason it's trial by fire, though, is I actually refactored the motion controller since I last wrote that network. So let's see if it still works. Sock. Put a sock right in the middle. There you go. Get a sock. I expect you to clean up my room. So the refactoring might have did it in, but the network is trying to pick that target and move towards it. And it is hung up on the trees on the blanket on the bed, I think, right now. I think it really wants to pick one of those up. No?
I mean, dark Christmas tree.
Yeah, it looks like a sock.
Very childlike. It makes
I do
sense.
think the refactor did that in. But anyway, that was worth a shot. I know I can still drive it around with my gamepad, though, and it was picking up socks before. Trust me.
I feel like it was just like really putting in the extra effort. It said this duvet looks like it needs a wash too.
So, you can teleoperate this, which means presumably you should be able to train networks to teleoperate this. That's what a lot of the other robots are doing. You teleoperate the robot, and you basically train a network to predict the teleoperation inputs from the video. And I tried that. It's hard. I basically tried using LayRobot's library. I tried training a transformer with like 28 billion parameters, and it doesn't work. I don't have enough data for that. It probably would work with more data, but with what I've got, I decided to settle on a way simpler solution. So that is, I just trained a way smaller model to locate the socks in the room. And that's all I've trained it on right now. I just click the socks, trains them. I got like a couple hundred examples. And then I trained another network to help me center the gripper. So that just takes the gripper's palm camera, which points down, and it predicts where the object is in the frame so that I can move over it and center the gripper over it. And then I have a little procedure that's basically kind of hunt and peck to try and pick up the sock. Surprisingly, that usually works on laundry in about 1 or 2 tries. But we're going to bring this over here where you can see it better. So it hangs from this gantry, and I'll talk about that later, but that's really to keep the lateral lines out of my head. This gripper is just a Raspberry Pi and a servo motor to open and close the fingers, and a servo motor to winch it up and down. Now, those are the only 2 motors in it right now. The rest of the motion comes from pulling on the strings that are coming from the corners of the room. Ow. I made it kind of strong. So it's got the shell on it that looks like the little Easter Island, head thing. I knew it needed a face. I had to put a face on it. Everything's more fun with a face on it. And I have like different colored shells, but I thought people keep asking me, why does it look like that? And I said, well, you want it to look like something else? And they said, yeah. So I'm working on like shells that look like anime girls and pineapples and bars of gold and birds and fish and whatever people want. I'm gonna sell hats basically. So you can put a shell on it and make it look different, but 2 fingers, practically all you need. And I'm particularly proud of the linkage on these fingers. Maybe that doesn't stand out to you, but check this out. These 2 fingers are driven by a single servo motor and they're linked by a gear. And yet the fingers move parallel when they're almost shut. But when they're almost open, they do that, which gives it like this big wide open grip to grab big old shirts and jeans and stuff. And yet when nearly closed, you get parallel motion. So that's just like a linkage where, you got a parallelogram, but it's not a perfect parallelogram. And then you can tune whether you want it parallel in some locations and not parallel in others. So this thing is hanging from these. And my dad was the one who said, please make it look like crown molding. Only robot that comes with strings attached. So inside of this, we have a camera pointing down at the room, a Raspberry Pi, a spool, and a motor. And it's driven by a belt reduction. It's about 2-to-1. And this little clicky switch, which is really important. When the line is tight, the switch clicks. If you don't know when the line's tight, then inevitably what will happen is you'll outspool line and it'll be loose and it'll form a rat's nest inside the thing. So it has to know when the line's tight. And half the trouble of running one of these things is keeping the lines tight. If you had a cable-driven parallel robot with only 3 wires, it would always be tight and stable. But with only 3, you can't reach the whole room. So you got to have 4 to reach the whole room. Now, this has no battery in it, which is another big benefit. We don't have to ship a battery. We don't have to pay the weight penalty of a battery. We don't have any downtime to charge a battery. We're delivering the power through this tiny line, which is actually braided fishing line and like 30-AUG FEP coated wire. So I'm supplying the power for the whole robot through one of the cables, which is using that same wire. And that means, and the fishing line bears the weight. So I can use this ultralight Teflon coated wire basically to deliver power to this guy. So why am I building a robot like this? Why not, right? But I'm building it because a cable-driven parallel robot that's open source and only focuses on a narrow and fairly easy set of tasks in the house is probably the only way you're going to be able to get a sub $1,000 or maybe sub $800 robot that can help you out with chores. Well, hi, James. And what good is the robot if we can't afford it? We got to be able to. Sorry. Dad, he wants to sit on my lap. This is James.
No worries. Hey, James.
And robot cleans them up. Can you say R is for robot? Oh, yeah.
And it's also a really great toy.
So yeah, we aim to just make something that can help you out in your house. I am trying my best to make this a reliable appliance that you turn on and come back in 30 minutes to less stuff on your floor. That is my ultimate goal here.
Yeah, I love that. I feel like it's like a really interesting step of like, so like there is this big push for these humanoid robots right now, but like what are we actually getting in that benefit of humanoid? And like we've gotten so conditioned to thinking that like this is the peak form, but when it comes down to it, like all you need is the grippers, and you don't necessarily
I like to say
need
tension is all you need. Right? You know that paper? So I might not be able to do this presentation if James is in my lap. Let me just take care of this. Just real quick. I'll be back in 2 seconds.
We'll give James a second to go hang out with someone else. But doesn't the string man look so fun? Just chilling there.
So, it's good to have a little special guest here. But before we go, I'm going to present my screen real quick because I want to show you the whole screen. All right. I want to show you the build guides that are available if you want to try and build one of these. Now, I'm actually selling them assembled if you want to do that. I don't sell kits, but I do have a really detailed set of build guides that guide you through printing and putting one together. So 4 anchors and a gripper. And generally, the motors and the cameras are going to dominate the price. But in the future, I'm going to bring the price down somewhat, maybe up, I don't know. But I'm going to try and alter it so that we have stronger motors and we have fewer cameras. Because what I've learned in operating this is that we don't need 4 cameras. We can get by with 2. And the cameras are Raspberry Pi Crema Module 3, which costs $35 each. So cutting out 2 of them saves us some money. This grip tape that's made for like finger skateboards is perfect for for grips on robots. Highly recommend it. I designed the whole thing in Onshape, which Control Tab, right? Oof, no, okay. Well, that's fun. Everybody likes to do that, right?
Infinite.
Yeah,
Screen.
Onshape. There we go. I designed the whole thing in Onshape because Onshape is a really great CAD program that, if you don't know a CAD program, and it makes it easier to share the document. So if you want, you can open this Onshape document and see how this thing is designed. Like I said, those 2 fingers are just linked by a single gear and a single servo motor that spins them. And yet we can get parallel movement here. There's other ways to get parallel fingers, but I like that because it's parallel when it's almost closed and it's not parallel when it's wide open. You get a good grip. So naturally, since we're on this stream, all of the CAD documents are open source, and the documentation on how to build it is open source, and the code that you run on your PC to control it is open source. And I'm actively working on it. In fact, I am probably going to start a single member LLC to work on it.
Nice.
And
that's exciting.
next year, I'll be able to work on this more or less full time and try to perfect it into what I was saying is I want it to be a reliable appliance, like a washing machine that you push the button and it picks stuff up.
It just works.
That is what I'm aiming for.
I love that.
I spend a lot of time just testing it and trying to get it to pick things up in my house. I have one down in the playroom, and I'm working on like a remote management app for it as well. So you can log in and drive it around from somewhere else as well.
Nice. That'd be very cool. I like that idea too. It's going to be really cool to see this like develop even more. It's already at such a great stage that I'm it's rad that you're already thinking about how it can grow beyond this. And
well, you saw earlier when I was demonstrating it that it missed steps on the stepper motor and the whole thing fell out of the sky. So we can't have that happen.
Yeah.
So we're going to go with some stronger motors.
Makes sense. Yeah. And yeah, I could very much see this being like the kind of the next thing in home care, home assistance, robotics, especially.
Possibly, yes. There are a lot of robot companies targeting that. I feel like if I'm going to put this in front of like a stubborn old grandma, it needs to be really reliable.
Yeah. Super reliable and very simple. And it is.
Very
like
simple.
It does the job it's supposed to do.
And this tendency for the gripper to swing below the gantry, that really isn't necessary. In the next version, I'm going to have, the gripper rigidly linked to the gantry.
Yeah, so it's just a little bit less swing to it, which I guess that makes sense too if you're doing like heavier items. If you're doing heavier items like jeans and sweaters. Yes, of course. Thank you so much for joining us, and thank you for coming to hang out too, James.
And if you want to try and find out more, check out newfangled.com, NEUFANGLED.com. Thank you.
Perfect. Thank you. Talk to you soon, Nathan. Oh, we love a special guest, and what a great special guest to have. One of the things that I really love about this project specifically is it does really feel like it is kind of the up-and-coming version of more ways that we can care for our homes without necessarily relying on humanoid robots, just because, we're used to the idea that this is the perfect gripper, but those two grippers work just as well, and if not better at times, because I know that my hands are not that strong in the long run. So being able to pick up a lot of different items and different sizes and complex sizes, like those two grippers can do a lot. Um, and on top of that, like we are hitting a point where there was a time where the automatic vacuum was like a really big moment in shifting home assistant cleanliness kind of vibes. And I think that this one is kind of the next step of like how we figured out how to vacuum automatically. Now, how do we actually get the floor ready to be vacuumed? You know, you got to make sure you can get all your socks off the floor before you can vacuum. That is just a consistent thing in my life. I have a lot of socks and they're always on the floor. So I really like the idea of not having them on the floor and I don't have to do the work of getting them off the floor because I am very lazy. Okay, so our final guest for today is the lovely Nicholas Mundez, who is going to talk to us about the Pipette Bot. Hey, Nicholas.
Hey Sid, thanks for inviting. Honestly, those were like great talks. I really loved the last one, and I think actually our robots are very similar, only in a very different settings. But I will kind of pick up where he left off.
Sounds good.
With that notion about being able to afford something that just gets the job done, doesn't need to be super duper expensive, right? So I'm trying to share my screen, and I don't know if that's happening.
Yep.
So
Shared.
I would start by showing you where I am. I'm on the road, so I won't be able to show much, but that's where I am in Bragado. That's Buenos Aires province, right in the middle of the agrarian zone, and that's Argentina, and that's the rest of the world, right? And it's almost like Argentina is the only thing in the map, right? Except for all of this.
Yeah.
But that's one thing. So that's that Argentina part in these slides. So my project, or the project I'm showing now, is Open Lab Automata, and particularly the pipetting bot, which is a sub $600 liquid handler, which includes, of course, open hardware, open software, and its documentation. It's one of the first tool-changing robots to integrate micropipette, which is an essential tool in lab work. So, perhaps like a carpenter would use a saw, microbiologist would use a micropipette. So this is an automated liquid handler is a good way to increase the throughput or just the amount of work you can do in a lab for particular types of assays, not for everything. So the idea is that lab observation gets to be for everyone and everywhere and for everything. Another thing I like about this project is that perhaps we can chain it to open regions, like the ones that are made by Reclone. So if we can chain open source tech with open source software with open source visions, we can have a little ecosystem of open source products and be able to, do all of the nice things we know we can do with open source stuff. So to sum up, the idea of this combination would be to do automated diagnostics that are low cost, in town, and viable in mid scale, and for research and development. So if everything goes well, I'll be able to show you the little bot. This is the 24 well speed challenge. So an interested buyer wanted to know if the robot could pipette 24 wells in under a minute. So without really doing any modification to it, and just feeding it what I had on hand, would happen to be wine, red wine. It got pipetting and serving little droplets of wine on the lid of a 96 well plate. It will get there eventually. But also, beyond having it doesn't only have a tool, which is the micropipette. It is compatible with the whole range of tools that the Jubilee machine uses, which was developed by Sonia Vasquez at Seattle. And there's a camera, which I also have here. This is one I reprinted and modified a little bit to work with what I had. But this also fits into the robot. So the robot goes, picks it up, moves, and does something with it. So the robot almost made it to 1 minute, under a minute, just over a minute, but that's okay, given that I didn't even tune it for that, so it could go much faster as well. There are many other tools. Although Julie is a 3D printer, mostly, it can be used also with this tool, so they are interoperable. And that was one of the objectives of this project, to be interoperable with other machines and not just play its own game, right? And let's see if I have another slide. So here are the links. We will go over them shortly. So we will first visit the source. So this is a talk for OSHWA. So here's the OSH part. The robot, the hardware for the robot is over here. I will show you also parts of the software, but really it's a rather large project, and it includes a lot of modules. So you will spend, if you visit this part, you will have to know what you're looking for. Otherwise, you just can go on and visit the documentation, which is made with Material MK Docs, and here you can start reading about it. Here you can see a couple of screenshots of the CAD, which was linked with FreeCAD. I really believe in that program, and that's what you need to use it. But it has been getting a lot better, and you can make complex assemblies much easier now. There's also a technical overview. Here's the pipette, which you can also show. It is a very bulky type pipette, but the most important part probably is the tip holder. So do not need to change between pipettes of different volume ranges. We included little steps here to fit the different pipette tips. And if you do pipetting, you know what I'm talking about. So you have to fit tips and then do the pipetting. And by doing this, we get one pipette instead of 3, and we bring down the cost from $1,000 for a pipette set to, I don't know, the construction cost for this is really low, like under $50. And yeah. So this is the head of the tool changer. So this part of the machine fits the pipette on this side, and that's the way it operates it. And perhaps we can talk briefly about the documentation. So the project has been going on for about 5 years now, a little bit less. And among all of the things that we did a small documentation site, which can be used by anyone. You just have to ask for a user, and we will review it because we are testing. So if you click on Browse Projects, here you get the stepwise guides for our liquid handler, and it's divided in lots of little guides. You can go into each one of them and start tracking your progress. So if you gather the parts, you get some confetti. You're doing great. And then when you finish with all of the steps and the nice additions, you get unicorns and more confetti and explosions. Well, then there are lots of steps because it is again a complex machine. But there you go. You can spend a week on this, and it will be a fun experience. What else? So in these links, I've already shown you the documentation site and the Stepwise Docs website as well, the GitLab repository, which you can browse. Here are some QR codes. Hopefully they work. And there's also Texi, which is a startup in University of San Martin in Buenos Aires, led by Gaston Corti and Martin Gambarota. And this is an Argentinian startup by researchers, founded by researchers, to try and make open source hardware for science. And I collaborate a lot with them because I also agree with the last presenter in that it's very important for open hardware projects to also have a commercial offering, even if it's a low volume or just, it must be out there. And this also happens to us. If we want to integrate open source hardware with the robot, like a Pocket PCR or something else, we need to be able to buy it, because we are already making the robot. So we need to buy the other things. We can't just make everything from scratch. So being able to buy open source hardware is very important, even to develop other open source hardware that depends on it. So it's very important also, I believe, to have a commercial offering. And here is Texi, which is an Argentinian company, but we can export. I have no commercial participation in this, so they sell it, and I get to play with it. So that's all of the links. I don't know if there's something else. Okay. If there's a little bit time, I wanted to show you the software stack for the robot. This is mostly it. So you have a front end, and here's the user. The Pacman is the user. You can interact with a web page, which has a backend. And there's a large Python program that manages the state of the robot and the tool changing and everything else. And there's the firmware layer below, which is really nice because you can use it. It's sort of firmware agnostic. We are using Clipper for this. So you can drive the robot with a pair of good old CNC shields, or with a duet board, or with a, I don't know, whatever control board you want. So it's not limiting to our hardware. And in this sense, we add another interoperability layer. So you have the interrupts on the tool side, and then you have it on the firmware side. So how you build the robot, and also how you use it. So there are many ways to communicate with this. We have integrated Pilot Robot, so you can program it with Python as well. And there are a few APIs as well. I will briefly show you how this works. So for example, you create a workspace, and in this workspace, you add labware, like this 96 wall plate, this box of tips, a Petri dish, a Pocket PCR, a trash bucket, and some tubes. You can add them. You can add more of them. You have them linked. And you can do all of this manually without needing to code anything, right? And then from this, you create protocols, which are defined as a sequence of steps. And you have different kinds of steps. For example, this transfer step transfers 10 microliters of water from a tube in the tube rack to the Pocket PCR here. And that's it. So you can just point, click, and slowly make your protocol, and then you just hit play, and it will work. And it will be exactly the same every time. So here's where automation shines. You have to have an essay that you do systematically a lot over the week, or over, I don't know, your work, daily routine. So you don't spend more time programming than actually doing the thing. So there's always a trade-off there it's good to have in mind. There are lots of robots just collecting dust because people thought they would solve everything like magic. And then there's, what else can I show you? So in the interoperability layer, so there's a little fast API to drive the controller. You have a lot of endpoints, and this is an easy way to publish them, but there are lots of entry points to the program. There's a little configuration editor, and I also have a gripper. But this is always parallel. It's not as fancy. But the idea is that it can spin endlessly to grab things like well plates and Petri dishes and spin things around. And this tool can fit onto the robot and be used by it as well as a pipette. And I think that's that. Yeah, you can visit any of these links, and there you can find contact information. We have a Discord. Well, hopefully it was interesting.
It was very interesting. A friend of mine is a lab worker, and I know how long he spends just going,
Yeah,
eh.
exactly.
So I think he would love to have.
Oh no, that was the wrong well.
Life.
I need
So-
to start.
Yeah, so I'm sure that like this is one of those tools that's like it's really what we are wanting to get out of automation. When we're talking about automating things in life, it's like, well, why are we wasting time automating ChatGPT bullshit when we could be automating the really actually like quite tense, stressful task of getting the right amount of liquid into one thing to the other, so you can actually test for the proper thing, follow the protocols all right. Your hand's getting crampy if you're doing that for I've not done it for a full day, but I know that he's had to do it for many full days of just pipetting back and forth. And I'm sure that it gets
Yeah.
quite exhausting. This is exactly
Yeah.
why we should be making these things.
Yeah, and try to make them accessible, right? So perhaps every level could have their own, or perhaps someone individually can have their own robot, right? So as you take to have your own tools, no, it's very rare to own the tools as a researcher, and this will allow you to own a tool if you want to, right? And then you
Yeah.
can take it and also empower yourself with automation and not just like the system itself. So I
Yeah.
think open source and lower, more accessibility and more interoperability and all of the things that we think are important
Yeah.
and will help people's lives.
It's true.
In
And I
way
feel
or
like it can be so helpful for being deployed in places where like they might be doing a lot of like citizen science or have less experience doing really intense in-lab research, where they can do a lot of field research with this and still feel like they're like following proper protocol and not getting too much cross-contamination because they have things in place to keep it clean.
Yeah, right. To separate the E operator from the sample in cases when it's hard to be near it, if it's a pathogenic or perhaps it needs an inert atmosphere, or there are lots of situations. Also, that one where it can be really useful.
Yeah, it's an amazing project. I'm really excited to see it grow and keep going.
Well, great. I'm very proud to be number 2 in this project from Argentina. In
We're
Oslo.
number 2. And hopefully we'll start seeing some more from Argentina, maybe from you. Maybe
Sorry?
maybe we'll start seeing some more certifications from you in Argentina.
Well, I have a lot of little things to certify, but I always try to, how do you say this? Evangelize people, to convince people to do the documentation and to, get their projects out there.
Yeah. Yeah, it's always great getting people more involved and just building awareness around what it actually means to do open source, because a lot of folks just don't know that it's an option.
Yeah, that's right.
Also,
I
thank
think
you.
I have had really great experiences, including this one with open source. So I'm very thankful to you as well.
Amazing. Thank you so much for joining us today, Nicholas. It was so cool to hear about the project.
Great. Thank
And
you,
good
Sid.
luck with wherever you're heading right now in the middle of nowhere.
I'm going home.
Oh, lovely. You're home safe. Bye. Okay, we've done it. Another amazing live stream. So many cool projects. I really love to see what folks are up to and get to experience kind of their thought processes and how they're coming to these stages and figuring out what's coming next. And it's always just like really great to see just the diversity of knowledge and how folks are coming up with all kinds of ways to use a lot of times the same parts, but in completely different ways, and put it together and doing so many different things. It's just such a cool thing. And now we are going to wind down for the season. We will be back next year in January, on the third Thursday of the month, which will be January 15th. So until then, make some cool stuff. Have some nice restful times as well in there, maybe. And we'll see you on the other side. Bye, y'all.